Large language models are sophisticated, but they suffer from severe amnesia. Think of them as digital goldfish. Once a chat ends, their memory wipes, resetting the model to its base training data. This creates constant friction for the user. Every time you open a new window, you have to re-explain who you are, your preferred coding syntax, or your formatting requirements. Resolving this amnesia requires an architectural layer called context engineering. It functions like a master chef's mise en place. Before the AI can process an answer, context engineering gathers the necessary ingredients, your past conversations, specific user facts, and available tools, and organizes them into a single payload. This dynamic assembly evolves a forgetful, stateless chatbot into a state-aware AI that actually knows you. The first layer of this architecture handles immediate context through sessions. Think of a session as a temporary workbench dedicated to the project you are working on right now. It holds the chronological, turn-by-turn log of the dialogue between you and the agent. However, every model has a context window. As a conversation grows, the workbench hits the limit of what it can process. This leads to token bloat, higher costs, and slower response times. It also leads to context rot. As the history grows, the AI loses its ability to pay attention to critical information buried at the start of the session. To maintain performance, systems use compaction. Background processes trim conversational filler or recursively summarize older messages to keep the core context active. Compaction prevents the session from collapsing under its own weight, ensuring the model receives a condensed prompt that keeps the AI cheap, makes it lightning fast, and aligned with your task. When a project finishes, you don't leave the workbench messy. You move the essential facts into a permanent filing cabinet, the memory system. This is often confused with retrieval augmented generation, or RAG, but they serve different purposes. RAG is a public research librarian. It fetches global, authoritative facts from a shared database, like technical manuals or wikis, that are the same for every user. Memory is your personal assistant. It is a highly isolated system that tracks your specific preferences and evolving goals, mapping them uniquely to you. How does the AI decide which parts of a messy conversation are worth saving? It uses an automated pipeline. First is extraction. A secondary LLM filters the chat history to isolate facts that match predefined memory topics. Then comes consolidation. Because our preferences change, the system must compare new data against old records to resolve conflicts. For example, if you previously established a deep loyalty to the Chennai Super Kings, that is your existing trusted ground truth. But if today you declare support for Royal Challengers Bengaluru, the consolidation step identifies the update. It intelligently overrides the old memory, rather than storing a contradiction. This pipeline allows the AI to act as its own archivist, maintaining a reliable, evolving record of your preferences for you. Fast forward to a future session. You ask a vague question, like, "Can you help me plan a trip?" without providing any new details. In the split second before the model responds, the system retrieves your consolidated travel history and preferences from the memory bank. The system invisibly places these facts into the hidden system instructions, or the conversation history. This pre-computation assembly provides the continuity and recall expected from a human assistant. The result is a precise, tailored response, a perfect travel plan, delivered without any hand-holding or repetitive explanations. We have transitioned from a forgetful digital goldfish to a context-aware, overpowered agent. Context engineering has evolved from simple prompt tweaking into the dynamic, automated orchestration of user data. By combining sessions and long-term memory, we create a personalized entity that continuously grows with the user.